together and make the world a better place.
That's a good. Yeah. So this is just the introduction of a program that has been going on for about 18 years. And here we have Dr. Donna Jones that I met 15 years ago. And she's a very acclaimed educator from Harvard. And I've known her for 15 years, and she's seen this organization grow. In fact, you have also seen a few of our students that here, and now they're successful adults. Now, all these students are below poverty line and below poverty line here and elsewhere. So I'm just going to introduce some of the work that I do and how do and this is, I'm basically, as I said, at Sloan Kettering Cancer Center, and I evolve technologies for detecting cancer in circulation for early stages. So basically, it's a field of micrometastasis when cancer cells try to move from one part of the body to the other and then causes cancer at stages. And that's why cancer deaths occur. So basically, we have evolved technologies to detect cancers in breast cancer, prostate, lung, thyroid, melanoma, and so forth. And one of the ways is through magnetic beads. In fact, we had a gentleman earlier who uses magnetic technology, but we use small little magnets to capture cells that I evolved at Sloan Kettering some 15, 16 years ago, and now we have these techniques to detect early detection of cancer cells through very simple blood tests, but these tests are genetic technology. This is just some DNA technology and to detect cancer cells in the blood from prostate cancer, as you see. This is from thyroid cells, just to show you how it is detected in the laboratory. And we use different markers. We also heard from the gentleman earlier about neuromarkers, but we use biomolecular markers to detect various types of cancer cells and how we can predict their living and control and cure for these diseases. So these are the different techniques that we use in our laboratory. These are some of the cells I can detect, or we can rather detect one cancer cell in 5 ml of blood. So these are different cells that you see in our microscopy. You see there are 2 cancer cells over there in different markers. So there are 2 cells, but they have 4 different markers, which means that there are different genes or different proteins, and we can detect those 2 cells from a variety of technologies. Here is a breast cancer cell looking for BRCA1 and BRCA2. Those women who have had breast cancer know this very well. In fact, now the women are leading longer and longer lives. Early detection is the best cure. And this can be applied in anywhere in the world. The best and the most complicated solutions are very simple solutions. We don't have to invest thousands or hundreds and thousands of dollars. Many things can be done at very low cost. So this is, again, you see those small little beads. There are 3 magnetic beads, those very small beads surrounding a cancer cell. So those are the technologies here you see, and then we capture them earlier. So this is just, so I just gave you a little a hint of what I do for a living, basically, and Harlem Children's Society is just one part of my life. And ongoing future work is to evolve, and we are evolving this in various other countries in Africa and Asia, so that we can, and many of the diseases prevalent in those areas. That's the very critical thing. Here we are affluent and in affluent societies, so we can evolve these tests much more easier. We have various patents that are filed. So this is one part of my life, and the other one that you just saw is about Harlem Children's Society, because I saw under-resourced, underserved students. There's a serious underrepresentation of those folks in the sciences. So 18 years ago, I started with 3 students in my laboratory, and then slowly all over New York City, and gradually to in different parts of the country. And over a period of time in various parts, about 25 countries worldwide. It's a very simple thing as as I said, even my science is also very simple. So these are the original first 3 students. I started my lab 18 years ago, and these are all 3 students are now all MD PhD students. They have double doctorates. There are 2 students on either side of me. They are both MD PhDs. One is a cardiologist, and the other is a neurologist. And the third person is a PhD in nursing. And they all started when they were 14 or 15 years old with me, and we've been tracing them for the last 18 years. So these are different research that these students do in different laboratories. It started in my lab, but then we have 1,000 students per year everywhere, and about 400 students in different parts of the world, in Kenya, Tanzania, Ethiopia, that we can also implement that in the Chad region as well. So it's a very rigorous program. These are some of the students over the period of all these years. And I'm just showing this as a quick photos of different, different stages. And we have various Nobel laureates come and talk to us, students, professionals. Here you see Dr. Axelrad, he got the Nobel Prize in Medicine 8 years ago, and various community leaders come in to give talks to our students. Here is a senator, and on the other side is a gentleman who ran for the New York governor. So when you do such things, obviously there are people who come and sort of add to, and we have another Nobel laureate on one side, and
just need to.
Okay.
We have another 2 actually more.
Okay. So you saw about the street fair? Okay.
Yeah.
Okay, so we can just wrap off, and that's it. Just briefly, is it over? Okay. Okay, so I'm just going to talk about this is a program in Ethiopia and Kenya. Okay.
We really have
And in Africa, rest of area. Thank you. Yeah.